Hello students. So let us derive an expression for electric field due to dipole at axial point. Actually there are two derivations. One is for axial point and one is for equatorial point. So in today's class let us derive an expression for electric field at axial point of an electric dipole. You know, electric dipole consists of two charges, right? Equal and opposite charges separated by certain distance, that is known as electric dipole. So let us consider two charges. One is plus q and one more is minus q. They are separated by certain distance. Okay? Let's take these two as charges. Okay, so this is the dipole. You know, the dipole length is generally taken as 2a, right? The distance of separation between that two charges, that is taken as dipole length, and generally we take that as 2a. Okay, that means if you consider the midpoint of the dipole, the distance of first charge from the midpoint, right? This one, here to here. If you consider this particular distance, that will be a. Similarly, for another charge also, from midpoint to another charge, that distance will be a. So total distance is nothing but 2a. Hope it is clear. You can name this midpoint as O. Okay, so this is dipole. Now we need to consider an axial point. So what do you mean by axial point? First of all, you must know what do you mean by axis. What do you mean by axis of dipole? Axis of dipole is nothing but the straight line which passes through these two charges. Okay, straight line which joins these two charges, or the line passing through plus q and minus q, that is known as axis of dipole. Okay, so if you continue this, just look at this. If you continue this line joining plus q and minus q like this, so now this is the axis. Okay, on another side also you can consider this is the axis. Okay, so somewhere on this axis, that means you can consider on left side or you can consider at right side. Okay, so you need to take one point in that axis. So let us consider some point P. Okay, I can consider one point P here. Okay, so this is an axial point because that point is on axis of dipole. No, if you want to take on another side, of course you can take that. Okay, somewhere here, that is also an axial point. Okay, yes. Now the P is the axial point. So what is the distance of that point P from the center? You can name that distance as R. Okay, so distance of point P from the center of the dipole or midpoint of the dipole, this particular distance, I will name this distance as small r. Okay, small r is the distance of point P, distance of point P from the midpoint of dipole, Similarly, if you consider charge plus q, so from that plus q, what is the distance of point P? Now you have taken this as R, and this one you know from midpoint to charge, you know, that is A. Using that, can you write the distance between point P and plus Q? Can you write this distance in terms of R and A? Yes, that will be R minus A, correct? So from point P to midpoint, distance is R, and here to here point, if you want you can name this. Okay, A, B. Okay, that will be easier. So now from A to O distance, you know, that is A. Therefore, if you want to get PA, the distance PA, that is R minus A. Correct, no? Similarly, what is the distance from minus Q? Distance from minus Q to P. What about this distance? Now you have to add this particular distance, right? It means that will be r plus a. Am I right? The distance of point P from plus Q is r minus a, and distance of point P from minus Q is r plus a. I hope it is clear. Okay. Now, what is our intention? We need to get an expression for electric field at point P, electric field at point P. Now, what are the electric fields acting at P? Actually, there are two electric fields. Why? You have two charges, right? So one is plus Q and another is minus Q. So at the point P, electric field due to two charges will act. One is due to plus Q and one is due to minus Q. Now, at any point, if you want to measure electric field, you know the method. You have to keep a unit test charge at that particular point. Therefore, you have to keep a unit test charge at P. Let us consider a unit test charge at P, that is positive charge, test charge is positive, right? Yes. Now, compared to this plus Q, this test charge is very small. Therefore, at P, the direction of electric field will be in which direction? You know, electric field is always from positive to negative. Or if there are similar charges, it will be from larger charge to smaller charge. The direction of electric field is from larger charge to smaller charge. Therefore, here plus Q is larger compared to this unit test charge. Therefore, electric field at P due to this plus Q will be along this direction. So, this is the direction of electric field due to plus Q. Okay. Why along this direction? Because this is larger charge, this one is larger charge compared to this unit test charge. Okay, so that is the electric field at P due to plus Q. Similarly, due to minus Q also, there will be some electric field at P. Now, what will be the direction? It will be in opposite direction. Why? Because charge direction is from positive to negative, right? Positive to negative. Therefore, plus unit test charge is positive, and here you have negative charge. Therefore, direction of electric field will be in opposite direction. Therefore, electric field due to minus Q is acting along this direction, that is E minus Q. Okay. Now, if you just look at the magnitude which I have written, the length of the line, so E plus Q is somewhat greater compared to E minus Q, correct? The line magnitude of E plus Q is greater compared to E minus Q. Why? Because, you know, electric field is directly proportional to 1 by r square. Electric field due to a point charge is proportional to 1 by r square. That means as r value increases, electric field value decreases, right? So in this diagram, you know, r plus a, I will write it here, r plus a is greater compared to r minus a, right? R plus a is greater compared to r minus a. Therefore, since distance and electric fields are inversely proportional, right? Therefore, here this plus Q is closer to point P. Therefore, its distance must be, so its electric field must be greater. Similarly, E minus Q is far away from point P. Therefore, its electric field will be less. That is what this length of electric fields represent, or the magnitude of electric field represent. Okay. Yes, hope it is clear. Now, we need to get total electric field at P, right? Total electric field at P. So, how to get total electric field? You need to add these two electric fields. Net electric field at P is nothing but vector sum of E plus Q and E minus Q. Okay. For that, we need to write an expression for E plus Q and E minus Q first. So, let us write expression for E plus Q. Okay. E plus Q. E plus Q, vector E plus Q. You know, for a point charge, electric field is given by 1 by 4 pi epsilon naught Q by R square, where R is the distance of that point from that charge, right? Q is magnitude of charge. Therefore, for E plus Q, for plus Q, what is the charge? It is plus Q, right? Magnitude of charge is Q. Therefore, 1 by 4 pi epsilon naught Q divided by distance square, distance of point P, distance of point P from this charge plus Q. What is that distance? That is R minus A, right? Distance of point P from this particular charge, that is R minus A. So that distance to square means R minus A square you have to consider. Okay, therefore this will be R minus A square. Since I have taken vector mark here, on right side also you need to write vector. So how you can write vector? Just look at this. We can compare this electric field direction with the direction of dipole moment. Electric dipole moment. You know, the direction of electric dipole moment is from negative to positive, right? Minus to plus. Therefore, here if you consider electric dipole moment, the direction will be from negative charge to positive charge. Therefore, minus to plus. Along this direction, the electric dipole moment is acting. Now, if you consider this E plus Q, that is also acting in same direction, right? Electric dipole moment is acting from right to left. Here E plus Q is also acting in same direction. So I will write here 1 by 4 pi epsilon naught Q by R minus A whole square into P cap, where P cap represents the unit vector in the direction of electric dipole moment. Okay, unit vector in the direction of electric dipole moment. So what do you mean by this expression now? Electric field is acting in the same direction of electric dipole moment. Okay, this says that the direction of E plus Q is in the same direction of dipole moment. Okay, yes. Now let us take that as equation number 1. Let us take that as equation number 1. Similarly, can you write expression for E minus Q? Electric expression for electric field due to negative charge. Again, 1 by 4 pi epsilon naught. Electric field due to negative charge. No need to consider negative here. Just magnitude of charge you need to write. Right? Therefore, that is also plus. Okay. Q. What about distance of minus Q from P? Distance of minus Q. Distance of minus Q from P. This distance. That is R plus A, right? So that will be R plus A. That one square, because electric field is proportional to R square. Into, what about the direction here? Just compare the direction of E minus Q. E minus Q, that is acting along this direction. That is acting along this direction. That means compared to direction of electric dipole moment, this is acting in opposite direction, right? E plus Q and dipole moment are acting in same direction, but E minus Q and dipole moment is from right to left, but E minus Q is from left to right. So they are acting in opposite direction. Therefore, I will write this as minus P cap. Okay, what does this minus sign indicate? The direction of electric field is opposite to direction of dipole moment. Is it clear? Yes. Next, so net field, right? Therefore, net electric field at P, that is E net, that is nothing but E plus Q plus E minus Q. Okay, E plus Q plus E minus Q, vector sum of these two. Yes, you name this as 3. Now what you can write? Substitute E plus Q and E minus Q from 1 and 2 in equation 3. What do you get if you substitute E is equal to 1 by 4 pi epsilon naught Q divided by R minus A whole square plus, okay, into P cap. Of course, you can write P cap here or you can take P cap outside because it is common. Anyhow, I'm writing it here only now. We can write one more step plus E minus Q, that is 1 by 4 pi epsilon naught Q divided by R plus A whole square into minus P cap, right? Yes. Now you can take common terms outside. So here 1 by 4 pi epsilon naught is common. Similarly, Q is also common, right? So I will take Q by 4 pi epsilon naught as common. Okay. So in first term, you left with R minus A whole square. And I will take this minus sign here. Okay. I will write this as R plus A whole square into, I will take this P cap outside. Okay, so this P cap is common, so I have taken that outside, and this minus sign is written here. Okay, plus into minus, that will be minus. Okay, now, so Q by 4 pi epsilon naught, you can take LCM here. Okay, just simplify inside the bracket. So if you take LCM, it will be R minus A whole square into R plus A plus B whole square into A minus B whole square, right? And cross multiply R plus A whole square minus R minus A whole square R minus A whole square into P cap. Now, just simplification, Q by 4 pi epsilon naught. Now, for this, you can apply A plus B whole square formula. What do you get? A plus B whole square, A square plus B square plus 2AB, right? So for this, you can take A minus B whole square formula. A minus B whole square, that is A square plus B square minus 2AB. Okay, so applying that, what do you get? Instead of A, we have R, and instead of B, we have A. So if you apply that and simplify, this will be R square plus A square plus 2RA minus R square, for that A minus B, right? R square plus A square minus 2RA, not AB, 2RA. Now in the denominator, minus B square whole square, like this we can write, right? R square minus A square whole square. Now this minus sign, you can take that inside. Four pi epsilon plus 2RA, and in the denominator R square minus A square whole square into P cap. Now if you simplify this R square A square and minus R square A square get cancelled. We are left with 2RA and 2RA, so that becomes 4RA, right? Or 4AR. So electric field, that is Q by 4 pi epsilon naught 4AR or 4RA divided by R square minus A square whole square into p cap. Now this 4ar, can you rearrange like that? 4ar can be written as, you can write this as 2 into 2a into r, right? Or you can write it as 4ar can be written as 2a into 2r, correct? No, 2a into 2r. So I will rewrite that one more step. Electric field, I'll write this as okay, q by 4 pi epsilon naught. And how to write this 4ar? 2a into 2r divided by r square minus a square whole square into p cap. Q divided by 4 pi. Yeah. Now, say, expression for dipole moment, What is the expression for dipole moment? Dipole moment equal to Q into 2a, right? Dipole moment is nothing but Q into 2a. Therefore, if you consider this Q and 2a together, this Q and this 2a together, can you write this as dipole moment P? So instead of Q into 2a, you can write it as dipole moment. Therefore, here only 1 by 4 pi epsilon naught is left, and inside the bracket, I will write that as P, dipole moment, into the remaining term. What is that? 2r divided by r square minus a square whole square into p cap. Okay. Yes. Now, if this point P is at a large distance from the dipole, that means if you consider R is very much greater than A, that means compared to distance A, this R value is much greater compared to distance A. If this R value is much greater, then you can neglect A. Okay, it means if you consider this point far away from the dipole, if you consider this point far away from the dipole, then we can neglect the length A. Okay, you can neglect length A. That means this denominator term can be rewritten, right? How? You can write r square minus a square whole square is there, no? This can be written as r square to the power 2, that is r to the power 4. Why? By neglecting this a, or if you substitute a equal to 0, then you will get r to the power 4. Now you substitute this one in this expression. If sorry, e is equal to 1 by 4 pi epsilon naught, in the numerator I write this as 2pr divided by r to the power 4 into p cap. Now one r can be cancelled, right? So r to the power 4 is there, so one r can be cancelled, so you left with r to the power 3. One by 4 pi epsilon naught 2p divided by r cube into p cap. Now you may know this unit vector. A unit vector can be written as vector A divided by magnitude of vector A, right? This is how we write unit vector. Therefore, here unit vector in the direction of dipole moment can be written as vector P divided by magnitude of P, or magnitude of P into P cap can be written as vector P. Correct? So P into P cap can be replaced by vector P. That means in this expression, instead of this, we can write which one? Yeah, this P cap. Sorry, vector P. Therefore, With that, we get the final expression for electric field. So E equal to 1 by 4 pi epsilon naught 2 into vector P. Why? P into P cap can be written as vector P divided by R cube. Okay, so this is the final expression for electric field due to a dipole at axial point. So if we look at the expression, it is clear that the direction of electric field and dipole moment are in the same direction. Okay, net electric field and dipole moment are acting in the same direction, and also electric field is proportional to 1 by r cube. Electric field is proportional to 1 by r cube. Okay, so very important concept for your board exam. This will be asked for 5 mark. Okay, just go through this once again. Okay, yes. Okay.